Hello and welcome to the series of lectures regarding the computer vision and basic topics we would cover are based on the image processing part. Then we would be talking about the computer vision, and then we would be talking about the AI, ML or DL based stuff. And generally when we are doing the AI for the computer vision, our final classifier is the neural network. So generally for neural networks we need the fixed inputs, and here fixed I mean the image size. So even if our object is of the size 110 into 110, we would resize it to 234 into 234. Similarly, if it is of the size 512 into 512, so we would also be resizing it to the 234 into 234. This is basically the topic of this video, that is the resizing of the input. That means either scale up or scaling down your input image. So first of all, let's talk about the scale up. So if we have 2 into 2 image, so we would be going to, let's say 4 into 4, and if we have 16 into 60, so we would also be going to 4 into 4. So now let us consider that our input images 10, 20, 30 and 40. So in the case of 4 into 4, so this would be something like 30. So this is what we want, and for that, based on the neighbors like D4, D8, N4 or N8, let us consider we have the N8 neighbors, so our output would be looking something like whatever I'm writing here. So we are just copying the pixels based on the nearest neighbor. So this is what we would be getting out of it. However, if we are going for sizes like 2 into 2 into 3 into 3, so our output should look like something 10 into x, 20 x, then 30 and then 40. So for such cases we can actually use for example averaging, or we would be using some formulation. So first of all, if we are looking for the averaging, so the average for this pixel would be 10, 20, so this would be equal to 15. This would be equal to 20, but we would be having the problem here. Why we would be having the problem here? Because one of its neighbor is not defined. So what we can do is, so average the pixels on the right hand side. So 20 plus 40, so this would be 30, 30 plus 20, so this would become 25, and this would in fact be equal to 35. So that means for such cases we would be using some algorithm. Okay. So now let's talk about the formulation. So let us consider that our formulation is basically x source is equal to x destination divided by 2, and y source is equal to y destination by 2. So if we are using this manipulation, and for 3 by 3, so 0 comma 0, so these are basically our output pixels, and here we would be having the input pixels. So 0 0 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2. So they would go to 0 0 0 0 0 1 0 0 0 0. So this would be 0 1 1 0 1 0 and 1 1. If you use this formulation, so this would be 10 10 10 10 and then 20 30, 30 and 40. So these were some simplified cases. So now let's take a look at a bit of difficult problem. So that is, for example, we are resizing 7 by 3 or 3 into 7. So whenever you have such fractions, basically you need to consider them areas. So it means you would be getting the numerator, this is basically your output, and numerator is your input. So you need to get 3 into 3 out of 7 into 7 input, or you need to get 7 into 7 output based on 3 into 3 input. So let us consider that our input image is looking something like 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 3, 4, 5, 6, and 7. And basically we are looking at the 3 by 7. So what we would do is we would be employing the uniform sampling here, means after a fixed resistance we would be sampling our input. So what we would be getting at the output is 1, 3, 5, 1, 3, 5, 1, 3 and 5. So this is basically the reduction of the scale down of your resolution. So if you want to go in the opposite direction, so it means that you need to increase the size, you need to put in the pixels, which would be, for example, here 2 pixels there, and there would another row that you need to add, and similarly the other rows here. Okay. So for such cases, practically we do not employ the formulations or the averaging, rather we employ the interpolation methodologies. For example, generally we employ bilinear interpolation as well as bicubic interpolation. So in the case of the bilinear interpolation, our basic formula is x2 minus x, y2 minus y, x2 minus x1, y2 minus y1, q11, x minus x1, y2 minus y over x2 minus x1, 1q12. Similarly for the second part, x2 minus x, x2 minus x1, y1 or y2 minus y1. So this will be 2, 1. And then we would be having x minus x1 over x2 minus x1, y1 q22. So if you look here, we are basically employing 4 pixels. So if you are looking for interpolation value here, so you need q11, q12, q21, q22, and based on these distances, which are basically these vectors, so you would be calculating the fx comma y. However, in the case of the bicubic interpolation, we have 0 to 3, 0 to 3, aij, xi, yi. If you look at the indices, so they are 4, this would also be 4, 4 into 4 would be equal to 16. So that means you need 16 pixels to actually calculate one value. So it means if you have 4 pixels here, you need additionally 12 more pixels. So this is basically the first 12 pixel, then these additional 4 pixel, and you would be getting the value there. Okay, but the problem with this formula is that okay, we know these xi's and yi's, but these aij's, they are unknown, so you really need to calculate that, and this is what we would be discussing in our next lecture. Thank you.